start and end will blur things properly, and with enough particles, it will kind of blur itself because all the particles will draw and create, you know, the circle of this wave. Do we want to make this an oval? Do we want like a radius 1 and radius 2? I think probably we want to be able to make oval waves. It's probably close enough. Alright, so why don't we have, we got optimizations and we got extra things, oval waves, and so take 2 radii for input wave. Well, I think we could code this out and it would actually work. It's not too many updates, I don't think. Because if we had a wave of, you know, 10 pixels, uh, 10 pixels wide. Where are my calculations here? Did I delete them? Here. So if we had 200 particles, a 33 pix wide wave. If that 33 pix wide wave was 10 pix, we're gonna have what? 200 times 10 pix. We're gonna have 2,000 writes. To actually write this entire thing out. That's starting to be a problem. Probably. It's not awful, but it's not gonna be free. We're already right into a fucking texture, so I mean. So we've already really thrown like, this is a free operation out the damn window. But 2,000 is not the worst thing in the world. Like 2,000 actual writes, as long as we're not doing any heavy math on this stuff, should be basically a 0. As long as we're not, like if it's 2,000 sine, is there like a shitty fast sine? Let's Google that, shitty fast sine function. Sine function not accurate. I mean, we could have like a sine and cosine lookup table or some shit like that, right? Like we could pre-compute that thing. So something we could use, is there like a pre-computed sine function, perhaps? I should actually look into if it already does like a pre-computed sine lookup table sort of thing anyway, because that's what I would kind of expect, is that we could do that. Well, I think I have enough information here. I can actually code this out. So I will do that. I'll be right back, and we'll start coding out the actual particle simulation for the waves. And I think we've got it all covered. It's just going to be coding it. Alright, well, I'll throw my cave drawings around. Close down this thing. And start figuring out how I'm gonna write this. Sorry, my mistake. I delete all links automatically. Because, yeah. You can always PM me the link and I can post it. But people on Twitch are not usually very trustworthy. It's people post things that you don't want to see. I mean, no, nobody would do that. Go on the internet and post horrifying pictures or racist shit. Nah, it doesn't work. Nobody does that. So we're going to stick this stuff. This is starting to get a little messy. I mean, it's already messy, so who really gives a shit, right? So we're going to have the internet as a peer environment. That's right. Yeah, those do look like human looks. What shadows are going on there? Like you're rendering out these things into your shadow map or whatever, and then all of a sudden, like, doesn't. I think something's wrong. All right, so we'll need our particle here. So we're gonna call this our wave particle, and it's going to have an f vector 2D, which will be the M world pause, a smoking kills campaign. Yeah. So we'll have a world position. We're gonna need an f vector 2D, a direction. We're gonna want a float. What's a good name for the size of the wave? I'd guess like the length. It's probably like wavelength. Might be a good name for the length of the wave. And then I guess, we'll just do the amplitude for, the size. It just kind of makes sense, right? That's some bullshit right there. Try to start off. We're going to want the int32 wave ID. Maybe wave scale. So we have the wave ID. Anything else we need on this thing? Yeah, I guess we want the... Man, we're gonna have to compute a whole bunch of bullshit for this thing. Alright, that's our wave particle. And why don't we just also just start with the optimization of not allocating anything. Let's just start with an array. And all that. So let's do a clear method on it. So we can basically disable these, and inside of our thing we're going to need a T-array of wave particles. So we do wave particles here. So we have X, Y, life. We should have X. Yeah, we'll just do X, Y, and life, and I'll make some stuff actually happen here. So we're gonna take all this garbage out of here, I think. So this needs to be an effector. I guess our position. Well, if we're just gonna go screw it up, let's just screw it up all the way. So let's just have like in32 particle num. Let's just set it to 200 to start with, and we're gonna go through and allocate all the particles that we need for this wave. Alright, I'm just going to do if waveparticles.num is less than 2000, then mWaveParticles. We'll just have like some shitty initialization function in here. So we'll make our max particle array. And I'm going to just mess around with this stuff. We'll clean up the code later. I just want to set stuff up here. So I'll have like a getNextParticle function. I'm just gonna make this a little bit optimized to begin with because I'm not very smart. Alright, so we need a wave particle ref get next particle function, and this next particle function is going to return the next freed particle to the list. So let's just do for 32 I equals. Let's just be even lazier. Let's just do a while true so that we'll just have an infinite loop here and be idiots. So we'll have get next particle. It's going to say in 32 search index is going to be last alloc particle. So search index plus plus and 32 searches equals 0. If searches Alright, so if search index equals last alloc particle, return null pointer. Alright, so we're going to need a wave particle pointer as a return value here. Alright, so if search index is greater than or equal to the number of wave particles, search index equals 0, and if we wrap all the way around here, then we'll do it. So if wave particles sub search index dot exists equals false, we're just going to return the address of wave particles sub blah. Alright, so this is just a grab the next unallocked particle, unused particle, clear particle, and last particle alloc equals search index. Alright, so we'll grab all of our particles, and then we need to fill out their positions. Alright, so for us to spawn these particles, we need to spawn them so that the middle, this is the position, so this is going to be supposedly the head of the wave that's coming out, so we want to spawn it what? This entire distance is the radius of the wave, so I guess just half the radius plus that, so we need to go around in a circle, so we need to know the angle at which we're spawning this thing. So the angle increment is going to be the particle, like, 2 pi There's not like a pi here? It's just pound defined. Okay. It's a pi. Just like that. Is there a 2 pi? So we'll divide by our particle number to get our angle increment. So our Kerr angle is just going to be what, I times angle increment? So our current position is going to be so we'll have the cosine of the Kerr angle multiplied by radius multiplied by 0.5f, and then we're going to add to that pos.x because we are in the xy area. And this will be the sine of the current angle. Alright, so that'll set the position. The direction is going to be, I guess we need the f vector 2D dir. It's going to be this whole ball of wax. Alright, so the wavelength is going to be just the radius. We're going to need a wave ID, so we're going to need a wave ID counter. So int32 wave counter. Int32 wave ID equals wave counter plus plus. Where we'll just do plus plus wave counter because who cares? Set the wave counter to 0. Just throw that in a block there. Probably move this. Alright, so the wave ID is going to be Wait, and this im exists. It's true. So we just made 200 particles, we just put them in the right spot, and all that fun times. Do we need to have a lifetime? I think we do, so we need to have, this is going to be a float life. Maybe we should just have death time. So we'll have our created time and our death time, and with that we can calculate our amplitude or something else. That seems reasonable to me. So I need my time utils here. Alright, so we got our get game time plus lifetime. Alright, so we have our created time and we have our death time. Alright, so a const vector reference here, just because we don't need to copy things. Cool, so we got this rolling along here. Alright, I'm just going to log this out and make sure we got our particles set up properly. I didn't set the direction. Do we want a speed for the wave? I think we do. So let's add a speed up on this thing. That should do it. Alright, so we shouldn't see anything except log stuff coming out, and we should run out of particles with, like, the 10th wave, because we're not doing anything with them. But we should see the waves spawn in a circle around the position. We should also fix our blueprint so we're actually passing in the correct stuff. Well, let's see what we can do with this thing. Because if we actually got, the rules correct for this, I mean, I need to do a few things in here to code, like, collisions with shore, but honestly, this isn't going to take that long to code out if these simple rules actually work. Like, then it'll just be like, there you go, there's waves, and be like, well, what the fuck, that wasn't really that hard. I say that now, though, and then it'll be like 3 weeks of me pulling out my hair. And then just giving up. And then buying a different house with an even deeper basement, and then just never coming out of it. Alright. Alright, so let's go to our fat sack water blocks thing. So check it out. I think I've got to fix the tick. Excuse me. I need a position here. So I need the top left and top right and all that garbage, I think. Alright, so we got the bottom left X and the top right X. Then we have the bottom left Y and the top right Y. And that'll be the X, and that'll be the Y. Let's just throw in 10, 10, 3, and a wave speed of 1000. Alright, we went all the way around to 1, 0. We went -1, -0. Alright, so 1 to 0, all the way to the right, all the way up, all the way to the left, all the way to the bottom, all the way to the right. We went around in a circle twice. Oh, we made 2 because I clicked it twice. We are making waves in 2 different places. Yes, that's what's happening. So what's wrong with our logic here? Oh, come on, Visual Studio, don't lock up on me. I guess we're supposed to be adding to the search index. I would have expected this to immediately explode. No, it's not going to explode because we're setting our last alloc particle and we're always succeeding. Cool. Alright, so particle number is working, everything like that. Looked like we had the right everything going on. If we're spawning in the right spots, the direction looks proper and all that sort of stuff. We got the right speed and everything. Okay, so we're going to need to go through every particle in our particle list and do stuff with it. So skip the ones that don't exist. So let's update our particle, and then we're going to write our particle to the texture. So the question here is also for this, we need to know what the last particle was that we wrote to a specific location so we don't overwrite it. So we actually need like a lookup for this thing. How exactly should we keep that? Should we just have that in memory as a lookup table for like last lookup? But the issue there, of course, is that we would need to clear it every single time, which is another big ass initialize for a whole bunch of data and shit like that. But we're already doing that once, so why do we care? Yeah, we've got an issue here where basically for particles that we are updating, we want to not update particles. We don't want to write to a location again for a specific wave, we just want to write once, but that's not really what we want either. I guess I can just write regardless, and I can just see what the hell happens. It means it might actually be a nice effect. We will see though. The game is finished? What? Yeah, there's gonna be water pretty much all over the place, and like this system is pretty, I don't know. It's still syntactic stuff. We'll see. There's a lot more about the game. We're just nailing down the visual look at the moment. Once we have basically the visuals and everything, Adam will know how to build all the assets we need to build the rest of the game. So yeah, it's just one more piece. So right now I'm trying to think about, because if we're writing this data in here, we need to, this F color is it's a U and 8, so it goes from 0 to 255. So it's an integer. Fuck. Alright, what am I going to do about that? I mean, I could keep... I guess basically I'm just going to have to keep my own thing here going. I guess if I do it on the stack, it'll at least be pretty fast. So, I mean, it might be fast. Fuck, I don't know. We'll just allocate a big chunk here. It's not going to be too big, I guess, if it's only like one float. But we might need more, so I'm going to do a few things here. I had an optimization there where I wanted to know if something had already written, and I was thinking I could update all the waves in order, so all the particles of a specific wave would update first. If the particles are in like a heap like they are, then we're pretty much screwed. I would have to have particle arrays for these individual waves that I would then run through to update. So I'd have like every wave would have its own little array of stuff, and we'd iterate over that, and those would all be pointers into the particles themselves. And I could update it that way. It's okay. We probably need to do that just to get this, so the N32 and last wave written. I think we need it. Gosh, but do we? If these waves reflect off of a surface, we want them to interfere with themselves. I mean, that's kind of the whole point. Why don't we do without the last wave written, and let's just write it all and see what it looks like. I need more caffeine. Alright, so if we update all the particles, how are we going to update these things? We want to, for each particle, write the current location for the crest. Right to our location, we have the first particle to actually write and click the wave. Alright, so we need to figure out the front and the back for our wave. So compute start of wave, compute end of wave, draw a line from start to finish. We need DT, don't we? Alright, so that'll create our new position. Alright, so we need our head is going to be our I guess we're just going to check, I'll put in checking shore stuff later. So this is going to be multiplied by the wavelength. So 0.5 times part.m wavelength. let's do effector 2D half wave. So the tail is going to be new pause minus half wave. And then we're going to want the... Why is this getting all pissed off? Because I'm missing a semicolon? Yeah, the animations are really cool stuff. That was what